Assalamu alaikum and welcome back. Today's lecture is bond length. What is bond length? What are the factors that affect bond length? We will discuss all these in detail and we'll also explain how a molecule gets ionic character from the covalent character, how a covalent molecule appear as ionic. So this is really this lecture is going to be very interesting lecture. So first of all, what is bond length? A bond length is simply the distance between the radius of two bonded, covalently bonded. So two atoms could bind with ionic bond, but keep in mind for bond length we refer to covalently bonded atoms first. So these two are covalently bonded atoms. The distance between the nuclei of two atoms is called bond length, not this one. This line is also the bond length, but this is not the nucleus. Nucleus is in the center, so the distance between the two nuclei of the atom is called, covalently bonded atom is called bond length. Fine. This was just the definition. Okay. The interesting thing is that in the lecture we would discuss that how this bond length decrease and increase between the atoms. This will be so interesting, and we would discuss why it is decreasing and why it is increasing. How the bond length is determined? We determine the bond length by diffraction techniques, X-ray diffraction. This is another topic, another lecture. Electron diffraction or other spectral techniques. These are all not the part of today's lecture, but at least we should know that with the help of this technique we determine the bond length. Now there are some points that I would like to explain. The first one is covalent bond length. This bond length is not dependent on the nature of the molecule. We could have different types of molecules. For example, if you see aliphatic hydrocarbons where CH, a lot of CH are there, less or a lot of CH are there. And here the bond length between the two carbon is always 154. Different kind of aliphatic hydrocarbons, if you take, the bond length is always 154 picometer. And if you come to diamond is also a compound, a molecule. In diamond, the carbon-carbon bond is again 154. So it means the bond length is not dependent on the nature. If the bond length was dependent on the nature, then it would not be the same in all cases. Then it would have been different in diamond and something else in hydrocarbon, different carbon. So this is the first point. Second point is additive in nature. What is meant by this? That if you want to know the bond length between the two bonded atoms, means if you want that this is one atom and this is another atom, and there is a bond length between the two atoms, and you want to know. So if you want to know that bond length, you do just one thing. You find the radius, radius, the radius of this atom and the radius of this atom. Find the radius. Do you know radius? Exactly, what is radius? This is an atom from the center to the outermost shell. This distance is called the radius r. So every atom has the radius. You just add the two radius and this will give you the bond length. Simply. Now, let me explain this. Carbon radius is 77 picometer. Picometer is the unit of length, like meter, centimeter, millimeter. It was a very small unit of length. So 77 picometer is the radius of carbon. And now if you want to add one carbon with another carbon, if you want to know the bond length, so what could be the bond length? You know that the radius of this carbon is 77 and this carbon is also 77. If you plus them, if you add them, you will get 154 picometer. Simple. Similarly, for other atoms, you can do the same practice. Like for chlorine, you can go same. This is the example of chlorine. One chlorine atom radius is 99 picometer. Another chlorine is also 99. So the two chlorine bond length will be 198 picometer. That's simple. Now the interesting thing that I'm going to explain is there are some cases where you cannot do the calculation like this. There is some kind of deviation. What is this deviation? Let me explain you. If you come to silicon, the atomic radius of silicon is 117 picometer. This is fine. And if you come to fluorine, the atomic radius is 64. Fine. If you add silicon with fluorine, definitely you will add 64 and 117. If you add 64 and 117, you will get 181 picometer. This is expected. Means we expect that the bond length would be like this. But in reality, the bond length is not 181, but it is 154, around 159, 155. Suppose it is 155. The bond length is 155, which is less than 181. This is interesting to know why the real bond length is less than the expected, or why the expected bond length is more than the real. The reason behind this is that in such kind of molecule like silicon fluoride, the molecule becomes ionic, means more ionic character comes, although it is covalent, yes, but in this molecule ionic character comes. So what is the cause of this ionic character now? What is ionic character? The cause of this ionic character is electronegativity difference. In this kind of molecule, the electronegativity difference is very high. Suppose if I say there is fluorine electronegativity is just 4, and suppose the silicon's electronegativity is 1. So if you subtract 1 from 4, the answer will be 3. 3 is a very big number from the electronegativity difference point of view. 3 is very big number. In other cases, the electronegativity difference is 0.1, 0.2, 0.3, or 1. But this is very big number. Even if you see 2 is also very big number. So in case of silicon and fluorine, the electronegativity difference is very high. This make the two atoms to come close together. As a result, the bond length is not that much, but the bond length is decreased this much. So ionic character develops. It means that ionic character appears with shorter bond length. Ionic character appears with shorter bond length. This is the reason. So this was the reason how a molecule transit from a covalent character to ionic character. So this was the reason. With this, you got it. Okay, now we will also discuss that what are the other factors that affect the bond length. It is hybridization. You know very well that hybridization is of 3 types: sp3 hybridization, sp2 hybridization, and sp hybridization. If you check in sp3 hybridization, there is 1s and 3p. 1s 25%, 3p 75%. S character is less, p is more. In this kind of molecule where the S character is less, p is more, bond length is high. Bond length is high. If you take sp, in sp just p is 50% and s is also 50%. So as compares to 25%, here the s character is 50%. So in sp molecule, the bond length will be more shorter because of the more s character. So I'm going to give you the example. In C single bond C, the molecule is sp3 hybridized. The bond length is 154. In sp2, the carbon-carbon bond length is 133, not 154, so become decreased. This is because of increase in S character, because here 25% S, here 33% S character is here, 33%. But here 50% S character, so the bond length is further decreased. This is the reason. And of course, when you come to the sp, there is double bond, and here there is triple bond, so pi electron also comes. The pi electron also tend to bring the two atoms close together, so we should also remember this as well. So this was the case of hybridization. sp hybridization, shorter bond length. sp3 hybridization, longer bond length. Now in the periodic table, the last part. In periodic table, you see there are groups and periods. From top to bottom, group, and from left to right, period. In group, the size of atom increases. For example, if you see there is one atom here, other atom will be short, slightly bigger in size, and it will be more bigger and more bigger. Remember, the two atoms, if they are small in size, their bond length will be less. They will attract each other with more power, so they will come more closer and bond length will be less. But when the atom size is bigger, these two will not come that much close together as compared to this one, but they will stay away from each other with some more distance, so the bond length will be increased. So in group, the bond length increases from top to bottom. Just keep this one sentence with you. And in period, everything is just opposite of what you saw in group. In period, the size decrease from left to right. So this kind of atom, which is bigger in size, bond length will be more as compared to this one, the bond length will be less. Okay, so let me give you an example of nitrogen and phosphorus for group wise. Nitrogen is at the top, phosphorus is below the nitrogen. So the size of nitrogen would be slightly less than the phosphorus. So as a result of this, if two nitrogen bonded together, the bond length will be less than the phosphorus because the size of phosphorus is bigger. And this is why such kind of questions can be answered very easily if you got a question in your examination paper, that why the distance between the two nitrogen is less than the distance between the two phosphorus atoms. So you will explain in this way. So this was all the lecture today of the bond length, what is bond length and how it is determined, and how a covalent bond length is independent of the nature of the molecule. You also got it. And we also saw that the covalent bond is additive in nature. In most of the cases, we just add the atomic radius of the two atoms, and what answer comes to us is the covalent bond length. But in some cases there is deviation, and this deviation is because of the increased electronegativity difference, and this electronegativity difference creates ionic character in that molecule. So we got it, and then we came to the hybridization. The hybridization also affect the bond length. sp3 hybridization bond length is very high as compared to sp hybridization, because in sp3 s character is less, but in sp s character is high. So more s character decrease bond length, less s character increase bond length. Okay, I got it. And then finally we saw in periodic table that the bond length increases from top to bottom because the size of the atom increases. And in period, the bond length decreases because the size of the two atoms are very less and they are very strongly attracted with each other. There was one more point, that nuclear charge. I have already discussed this in my another video. Nuclear charge is the number of protons. Nuclear charge is the number of protons. So in the case of period, the nuclear charge is actually increasing from left to right. The nuclear charge attracts electron, so the atom size become shrink and become decreased because the protons in the center, they attract electrons, so the atom overall become decreased. So here nuclear charge is very high, but in this case the nuclear charge is less. So I'm thankful to this, that I remind about this nuclear charge as well. So this was all the lecture today. You can just have a screenshot of it, and we'll see you in the next video lecture. Take care of yourself.